Good morning, students. Today we are going to start third unit of crash course, that is motion of system of particles and rigid body. Again one important topic from which every year getting one problem. What is motion of system of particles? If you applied a force on a body, definitely it will be accelerated because A is equals to F upon M. We want to check if we have one single particle and by applying that force, it will acquire same acceleration, means same type of motion. If it can perform, then that single particle which can replace this whole body is known as center of mass. For regular bodies, regular shapes, it coincides with center of gravity. So we are going to discuss center of mass. Where you will find the center of mass? Not a tough formula. If you know all particles which are forming your system, suppose their masses are m1, m2, m3 dot 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 mn, and their position vectors are respectively r1, r2, r3 dot 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 rn. You will find center of mass at a point whose position vector is defined by m1 r1. You have a derivation complete in your 11th class, m2 r2. I am just recalling you all the facts, plus mn rn divided by m1 plus m2 dot 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 mn. In short, you can write summation of products of mass and position vector divided by summation of mass. If you remember this formula, you can get all formulas from this. Means if you want to calculate velocity of center of mass, no tension. What is velocity? Rate of change of displacement. It means differentiation of this, you will get VCM. You know the rule of differentiation. M1 is constant and differentiation of R1, it will become V1, and denominator is constant as it is out of the sign of differentiation, and as it is it will come back, plus M2 V2 plus M3 V3 dot dot plus Mn Vn divided by M1 plus M2 dot dot Mn means summation of product of now mass and velocity of all particles divided by summation of mass of all particles. Similarly, by differentiating VCM, you will get RCM. Summation of mass and acceleration now divided by summation of mass of all particles, means capital M. If you are denoting total mass with capital M, and denominator you can write capital M, mass of whole object. If you have a continuous distribution of mass only, then replace your sign of sigma with the sign of integration. For continuous distribution, you can do this, replace sigma by sign of integration. So, not a tough task. In competitive exam, they can ask you this type of problems also. I have a molecule HCl. H plus Cl minus HCl. They will give you distance of H and Cl. Where is the center of mass of this system? They will give you this distance. Suppose distance between H and Cl is R. You know that, and by chemistry you can find the mass of this is 1 if mass of this will be 35.5. How to find center of mass? Take one particle as origin, suppose it is origin, and center of mass is at x distance from this. So, its distance from Cl, it should be R minus x. So, what is the formula for center of mass? M1 R1, since I am taking H as origin, so it is 0, plus M2 R2. What is R2? R2 is R, because this particle is from origin at R distance, upon M1 plus M2, 36.5. So, you will get the position of center of mass from origin. If they are asking from hydrogen atom, tell them x. X means where we are getting center of mass. You got this distance, this is your x. Actually, we take at x distance, so you will get this x, position of center of mass. If you want to tell from chlorine, subtract from R, you will get your answer. So, not a tough problem, some easy problems they can ask in your exam. Next thing you have to learn, angular momentum. Before this, you know kinematics. So, better to remember analogues of rotational motion, analogues of that kinematics. Means in rotational motion, which quantity is replacing which physical quantity of kinematics? Learn that. In a rotational motion, we are talking about analogues. So, no need to learn any formula, all you will get directly. The role of mass which you are studying in translatory motion, in this chapter it will be played by moment of inertia. I will tell you what is moment of inertia. Moment of inertia is a tensor physical quantity. Tensor physical quantity. In rotational motion, suppose you have one object made up by 3 particles and it is axis of rotation. And all particles have masses m1, m2, m3, and from this rotational axis their distances are r1, r2, r3. Then moment of inertia is defined by summation of mass and distance from rotational axis square. This, it is known as moment of inertia. Means in general you can write I is equals to sigma m r square if your system is made up of n particles and you know the distances of all particles from axis of rotation. Take summation of product of m and r square, you will get moment of inertia. So its dimensional formula should be ml2 and unit should be kg meter square. Why I am saying कि moment of inertia is a tensor physical quantity, because by changing the axis of rotation it will change. Means in different directions moment of inertia is different, but it is not obeying the law of addition of vectors. That's why we are saying it is tensor physical quantity. So analog of mass is moment of inertia. Analog of linear velocity is angular velocity. Analog of linear acceleration, angular acceleration. Analog of force is torque. Analog of linear momentum is angular momentum denoted by L. So you can make your own formulas for rotational motion. Suppose you know that what is force. Force is mass into acceleration. Torque we have already discussed in so many chapters. One definition is this: force and distance of perpendicular distance of force from axis of rotation. That is still here also. Means that is definition is valid for this chapter also. What is torque? Force into perpendicular distance of force from axis of rotation. But we can compare this result. M's role it will be played by moment of inertia. In place of A we will put alpha. So one more formula for torque is I alpha. Getting my point? One more formula for torque is I into alpha. If we want to calculate angular momentum, what should be its formula? Angular momentum means linear momentum m into v. So we can write in place of mass, what should you write? Mass role I will play, and velocity, angular velocity. You know the law of conservation of linear momentum, because definition of force was rate of change of linear momentum. In this chapter, force is replaced by torque. So torque is rate of change of angular momentum. One more definition. If torque is absent, means 0, we know that only differentiation of constant is 0, so L should be constant. It is known as law of conservation of angular momentum. Torque is equals to 0 will leads to the result L should be constant. Getting my point? In this way, it should be not C means constant. You know Galileo's equation. Their analogues are present here. What was Galileo's equation? V is equals to U plus minus AT. S is equals to UT plus minus half AT square. V square is equals to U square plus minus 2AS. What we will do here, in place of V, we will denote angular velocity by two terms, omega naught initial and omega is final. So we will write omega is equals to omega naught plus minus alpha t times analog is time only. In place of linear displacement, angular displacement should be there. So omega naught t plus minus half alpha t square. Third relation, omega square is equals to omega naught square plus minus 2 alpha theta. So we got all three relations in this. So many questions they can ask on the law of conservation of angular momentum. In which type of questions they can ask? Suppose you are standing on a turning table. Table is rotating and you are standing on that table. If suddenly you fold your arms, initially your arms were in this position. You were standing here. Your arms were in this position. And what you did? It was a rotating table. Suddenly you fold your hands. What will happen now? Since in this case, sum of mass, it is axis of rotation. It is axis of rotation. So this mass was away from this. And after folding your hands, all mass is now near to the axis of rotation. And we know that what is I? I is equals to mr square. In this way, you decrease the value of I, but no external torque was present there. So L should be constant. L should be constant. So if initially angular velocity was omega and now it become omega dash, but L should be constant, product of I and omega. Since you decrease the value of I, it means you increase the value of omega. So omega will increase, means omega dash should be greater than omega. So this type of conceptual problem they can ask in your exams. Getting my point? What I am saying, I is equals to mr square. It is different for different objects we will discuss. But if you have one distance, means I is equals to, in actual, summation of mr square. If your object is made up of so many particles, I should be equal to sigma mr square. If you have one distance, by multiplying square of that distance with whole mass of object, if it can give you moment of inertia about that axis of rotation, then this distance k is known as radius of gyration. It is known as radius of gyration. It will play a very important role when we are going to solve some type of numericals. So it was all about that radius of gyration. You will see in previous year exams, sometimes they are directly asking, tell us radius of gyration of ring about this axis, about that axis, about disk, for disk, for sheet, plain sheet, for a rod. They can ask directly, and they are asking. So we will discuss that point also. So it was radius of gyration. So you have to learn moment of inertia of some regular figures about their own axis. Their own axis means perpendicular to plane and passing through the center of gravity. So we have to learn some moment of inertias. We will discuss two types of theorem. Then with the help of that, you can calculate moment of inertia about other axes. They are asking in exams that point also. So we will discuss theorem of parallel axis, theorem of perpendicular axis. Only two theorems are there. And we will discuss the motion of a body. First, I am telling you, suppose motion of a body. Three types of motion may be there. Three possibilities are there. I have this one sphere, solid sphere I am putting here. If you are pushing the solid sphere by a force F, if it is smooth surface, it will slip on this. It means only you will observe translatory motion. But if this surface is rough, due to that interlocking, it will roll also. It will roll also. So translatory motion is there and rolling is also there. You will observe rolling motion plus translatory motion. Means due to friction, you will get torque R cross F. It is R cross F. Friction is acting in this direction, so it will start rolling. So you will observe two type of motion. Of it is not free to move, then it will purely rolling motion. It is only rolling motion. So it means there are two types of kinetic energies. In purely rolling motion, kinetic energy, it should be half mv square. Role of m, I is playing, and in place of v, omega. In purely translatory motion, you will get half mv square. But in this total kinetic energy, for total kinetic energy, you have to use the formula half mv square plus half I omega square. Getting my point? So don't be confused if both motions are there and they are talking about kinetic energy. It means they are talking about total kinetic energy. In 4 options, definitely they will put only rotational kinetic, only rolling kinetic energy, only translatory kinetic energy. Their sum should be there. And 4th option they can make any one. So don't get negative marking at that point. So it is the point, motion of a body. It can be translatory only, it can be rotational plus translatory, it can be only rolling. Rolling and translatory both are possible only and only if friction is present there. Getting my point? Rolling is possible due to friction. So now we can discuss the motion on an inclined plane. If you have, and remember always, if both type of motion is present there or translatory motion is present there, velocity of center of mass you can calculate by, if both a type of motion is there, velocity of center of mass you can calculate by omega into r. If you put an object on one inclined plane, both motions are present there because this surface was rough. If this height is h, it means at this point your object has potential energy mgh. When it will be rolled down and at this position mgh disappears. Where mgh is gone, you can calculate by sum of two kinetic energy at this point, means translatory kinetic energy plus rotational kinetic energy half I omega square. Since we know that V is equal to omega into R, so we can replace this by this also. mgh is equals to half mv square plus half. Suppose moment of inertia is mk square, where k is the radius of gyration, and omega you can write v square by r square. Cancel m with m. We are denoting mass by small m, so we will write small m. Cancel mass, mass, mass. So what we are getting, 2gh is equals to, take v square common, 1 plus k square by r square. So in this way we are getting one good result. Velocity of particle when it will reach bottom, its velocity should be, or square of velocity should be 2gh divided by 1 plus k square by r square. In competitive exams, they are asking about, they will give you 3 figures: solid sphere, ring, disc, cylinder, hollow, solid. Who will reach first? From velocity you can check. If for one object k has more value for one object, k is in denominator, the big value of k will make denominator big, it means whole number will reduce, so value of v will be less for that. So for which object k has greater value, that object will reach last, because velocity is less for that. It will move slow. So in this way we can calculate who will reach first. So in competitive we have to keep mind in this, who will reach first, which has more value of k, that will reach last.